Hello, welcome. Today let's try to solve another Leetcode problem, 100, same tree. So we are given two nodes P and Q, and we want to check if the tree P and Q are the same. So let's check first. So for the first example, the root node is the same, and the left and right side node is also the same. So we're gonna return true. And let's check the second case. So for the root node, it's the same, but for the first tree, it has a left side node, but for the second tree, it has a right side node. And let's check the last example. The root node, they are the same, and from the left side, it has node, but the value is not the same. Yeah, actually, we can use these three examples, to find a clue of how to solve in this problem. Let me first go to the whiteboard first. After that, I will go to the code editor to finish the coding. So for solving a tree problem, most of the cases we're gonna use a recursive solution because this will be easier. Yeah, if you can't think of the conditions for the recursive solution, you might use the iterative solution. Yeah, basically for the iterative solution, you're gonna use a queue and to check level by level if they are the same. Or we can use a iterative solution. It's basically like the pre-order traversal. We're gonna first check the root node, and then we're gonna check the left side and then the right side. Yeah, let me explain it. Yeah, so first we're gonna check the root nodes. Yeah, if the root node they are the same. If they are not the same, we're gonna return false. Yeah, if it is the same, we go to the left side. And then we are going to check the left side of the tree, they are the same or not. Yeah, if the left side is the same, then we're gonna check the right side. Yeah, if the right side is also the same, so we're gonna return true. So if any conditions we find, for example, from the left side, we're gonna return false. Yeah, we find false, so we're gonna return false immediately. Yeah, and how can we find the conditions? Yeah, so what is the true or false? So for the conditions of true is that if we find this node, for example, this node 2, they are the same. So for the recursive solution, it will go to the child. So the child for this node 2 is none. So left side and right side both none. And for this 2, it's also the same. So it will always be none. Yeah. So if it is a none, so we're gonna return a true. So for example, this is none and this is none. If they are the same, and P and Q, if it goes to here, they are the same and it's none, so we're gonna return a true. So similarly for the right side, if it is a none, we're gonna return true. So this means this node is true from here. Yeah. So what conditions we're gonna return false? So if the left side has a node, for example, for the root node, the left side has a node 1, but the right side has nothing, so we're gonna return a false. Yeah. Also, if the value is not the same, for example, if the node value is 1 and this node value is 2, but they are at the same position, so we're gonna return a false. Yeah, so from here, we're gonna write our recursive function. Now let me go to the code editor to finish the coding. Yeah, basically we need to find the true or false. So what conditions for true, as I explained? So if not exist, if not Q, and not P, so we're gonna return a false. We're gonna return a true. Yeah. So this means, from the beginning, if the tree are not exist, we can return true. If P and Q both not exist, we're gonna, let me first write P and not exist Q. Yeah. Also, if we check all the node and then go to the leaf node, and from the left side and right side both none. Yeah. If we come to here, so it means we've already checked all the conditions, so we're gonna return a true. Yeah. But before that, what conditions we can return a false? So it will be if P and not Q, we can return false. Yeah, because if P exists, so if one node exists, for example, if here this node exists, but for this tree the Q does not exist, so we're gonna return a false. Yeah. Similarly, we can check another condition. If Q and not P, we can also return a false immediately. Yeah. And the last condition is, yeah, so from here, there's always one node not exist. Yeah, and this condition is both two nodes not exist. So the last condition is, yeah, the node must exist, but its value does not exist. So we're gonna check the value. So if p.val not equal to q.val, we can return a false. Yeah, so the last condition means this p and q already exist, because after checking these three conditions, we are sure the root p and q must exist. So we're gonna check the value. If they are not equal, we're gonna return false. And then if everything, yeah, is okay, yeah, from here, if we already checked the root node, for example, so the final return, we're gonna check the left side and the right side. Yeah, so we're gonna return self dot is the same tree, and p dot left and q dot left. Yeah, if the root node they are the same, for example here, so we're gonna go to the left side and then go to the right side, and this is exactly like the pre-order traversal. Yeah, now let me copy this line. Yeah, and just change this p to the right side and q to the right side. Yeah, now let me submit it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. So here, there's a non-type. Object has no attribute val. Yeah, so this is inside P. There's no node. Yeah, there must be something wrong. Yeah, because here I did some typos, as you can see. If P and not Q, so if Q and not P, yeah. Only in this way we're gonna check all the conditions. So this is a typo. Now let me just submit it to check if it works for all the testing cases. Yeah, as you can see, it works for all the testing cases. Yeah, it seems quite slow, but it doesn't matter because we're gonna analyze about the time complexity. It is still O(n). N is the number of nodes inside P or Q. Yeah. Now let's optimize the code a little bit. Yeah, we're gonna copy this line and put it here. We're gonna use the OR, and we can use another OR and put it here. Yeah. Yeah, because we don't want to make so many conditions. Yeah, just clean up a little bit of the code. And now let me submit it to check if it works okay, because this basically check all the conditions for false, and this is the only condition for true. After checking those two conditions, so we're gonna go to our recursive function, check the left side and the right side. Yeah, now you can see it works seems quite fast. Yeah, much faster than before, but it does matter. Yeah, because the time complexity is still O(n). N is the number of nodes, minimum number of nodes inside P or inside